Here again, teaching you about stars and the HR diagram. And so this week we're going to kind of recap on stars, look at how they are categorized, what makes them, the differences between each of them, and then we're going to look at something called the HR diagram. And so this is a chart, a tool that scientists use to be able to categorize these stars and to be able to kind of organize them so that you can find them easily and just kind of know a little more about them. So as a recap, what are stars? They are burning balls of gas that come in different sizes and they come in different colors. If you go outside, look up in the sky at night, if it's clear, you'll see that there are thousands, billions, trillions of stars there, and a lot of them are somewhat close to us, being the sun, that's the closest, and then a lot are light years away, very far away. And they all, though, burn at different temperatures, they have different colors, different sizes. Now, they come in different sizes. They can be small, average, kind of like our sun, and massive. They come in different colors. Remember, for stars, color equals temperature. Cool stars are going to be red, and hot stars are blue. Cool and hot, think of kind of like the color of fire, that flames that are red and orange are going to be cooler compared to flames that are blue and or white. Now, these stars can be grouped into three major categories: by their size, by the temperature, and by the brightness or the luminosity. So luminosity is how bright a star actually is and how it appears from Earth. That's where if you went out at night, looked into the sky, you'll notice that there are some that are just that twinkle brighter than others. That could be because they're closer, but it also could be because of their size. If a star is very, very large, if it's a massive star, it's gonna have a higher luminosity than a smaller star. Just in general, something that is bigger, something that's hotter, has more energy, is gonna release more energy, so it's gonna be brighter when compared to smaller stars. So these stars are like I said, are categorized or organized on something called an HR diagram. So you're gonna watch a brief video from YouTube, though, about something the Hubble telescope has discovered and picked up on. To do this, I'm gonna have to turn the microphone off on this screen recording, so give me a second.
This is a Hubble Space Telescope image of the crowded core of the globular cluster Omega Centauri. The brilliant colors of the stars are real. They correspond to stellar temperatures. They can also be used to trace stellar evolution. Astronomers like to know how blue the blue stars are and how red the red stars are. So we'll first sort these stars out by color, blue on the left and red on the right. Next, we'll sort the stars according to brightness, the brightest stars at the top and the faint stars at the bottom. The final plot you see represents different stages of evolution of stars. Stars spend most of their lifetime burning on the main sequence. When their fuel starts to run out, they expand to become red giants. They find a new source of fuel, helium, and burn blue hot, but even that runs out. They end up burning out as white dwarfs. Based on images for the Hubble Space Telescope, we've assembled a true plot that is a snapshot of the life history of stars in this ancient cluster.
And so that brief video was showing how the Hubble telescope was able to take pictures of all of these stars and how they're organized or categorized on this HR diagram. So that was a real life picture of stars. And so we're going to look at this HR diagram and kind of label it. So I know there's a lot of circles, labels, all this seems a bit overwhelming. The main part of this HR diagram, like the questions you'll see when it comes to your test or anything like that, 8th grade wise, is really just looking at how to read the diagram. And so we'll fill in those circles in a little bit, but first let's look at the X and Y axis. So if you look down here at your X axis, if you look down here, you'll see the temperatures down below. They have it listed in Kelvin, but notice how on the right side you have the cool stars, like the smaller number of temperature, the cooler temperature, but as you move to the left it increases. So this is the exact opposite of any other type of graph that you would see in math and science, anything like that. And so that's kind of the key focus on this one is just be aware of the temperature. So that means that on the right side of the HR diagram, that's where you're going to have the cooler stars. And then as you move to the left, they get hotter. Now, looking at the y-axis, so looking up and down at this axis, this shows the luminosity. This shows you how bright a star is. So remember, the luminosity is compared to the sun. And so number one, this is kind of the middle ground. So that means that at the very bottom, you have your dim stars. Dim meaning that it doesn't give off a lot of light. It's a very small amount of light and energy. And then as you move upwards, the stars get brighter. So that means that any of the stars located along the very top, they're going to be brighter than whatever's located at the bottom. So let's fill in these circles so we can start kind of seeing, because the HR diagram follows the life cycle of a star. So when these stars are formed and once they start producing light, that's our main sequence stars. So notice how this circle takes up a lot of the HR diagram because there's a big variety of stars that can fit this space. Because it all depends on the amount of energy that they have when they first form, the size that they are. And so you'll find down here you'll have cool stars. As you move up and to the left, that's where you start to get your hot stars. So main sequence has a big variety of them. As the stars live out their life there, they then become red giants. So once those stars start to lose their energy, start to get older, and the outer layers expand, it turns into red giants. So these are going to be less bright than the others. They're not as hot, and they're smaller in size. From a red giant, they can turn into a supergiant. These stars are going to be very bright, but they're not that hot. Those that are over here, of course, as you move over here, they get hot. But these are going to be very, very bright stars because they are massive stars. They are super giants, okay? The name's for a reason. And so they put off all this light. Now, as supergiants and red giants, once they begin to lose their power, their energy, they then become white dwarfs. And so these white dwarfs, they are very hot, but they're dim and small. And so notice how in luminosity, how they're on the bottom half of the HR diagram. So they don't give off a lot of light, but they are still very hot. And so let's look at this. So this is the same diagram. These colors are going to be the colors of the stars. Now, some HR diagrams you'll see are color-coded this way and others aren't. So that's why I was showing you a variety of them. But over on the right side, you have your cool stars. On the left side, you have your hot stars. And then the bottom is dim. And then as they move upwards, things begin to get brighter and start to produce more light. So let's practice reading. We've got several questions here. We'll practice reading an HR diagram because essentially when it comes to your assignments and anything like that, this is what you are graded on. So looking at this HR diagram, we have it color-coded. It's already labeled with our temperatures, with our brightness. And so we're going to kind of pick out some stars and go from there. So the first question says, where can you find the brightest stars? So if I look at my y-axis over here, my luminosity, it increases as I move up. So any stars, any bright stars are going to be up top. So I'm going to put at the top. You don't need to write any of these things down, but I would refer back to it before you have to go and take or work on your actual assignment because some of the things here could be very beneficial. Where are the coolest stars located? So looking at surface temperature, 3,000 is a lot less than 50,000. So all my cool temperatures are going to be on the right side of the diagram. So that means that all of that colored red, all colored red, orange, those are going to be a lot cooler or colder than the blue and white stars. All right, looking at this, where can you find a hot star that is dim? So anything that's hot is over here on the left. And then I have my luminosity, it's dim at the bottom and bright up top. So where can I find a star that's hot and dim? It would be the bottom left area. What star could be cool and bright? So my cool stars are over here. Remember, bright is up top. So I'd be looking in somewhere like this area. So my answer could be either Betelgeuse or Antares. It's alright if you can't pronounce these things. I just kind of make up the sayings of them. But my answer could vary on that one. It could be any of those stars up in that top area. Question 5, name a blue main sequence star. So this one helps us out because it's color coded, right? Shaded in on all those areas. It's not always going to be that way. So this one though, so blue main sequence, so I only need to look at this area, and then main sequence is this section here. So I'm looking at anything in that area. I could name off any of the stars. I'll just put Spica just because it's the shortest one to write. But it could be any of those. And then 6, Deneb can be categorized as what type of star? So first, let's find Deneb. All right, so it's right here. So looking at that, I could say, so when they say what type of star, they're saying, is it a white dwarf, a giant, main sequence, or supergiant? This one is in this up top category, so it's going to be a supergiant. But let's go a little farther and see, like, let's describe it a little bit more as far as characteristics. So Deneb, is it going to be hot or cool? Considering that it's in the white category, it's going to be hot. And then as far as luminosity, is it bright or dim? So remember, dim is down below, 0 is down, and then it gets brighter as it moves up. So Deneb is going to be a very bright star. All right, compare Rigel and Deneb. So again, about Deneb, where is Rigel? Somewhere, oh, right next to it. So these two, the dots are about the same height, so they have the same luminosity. And then temperature-wise, Rigel is slightly to the left compared to Deneb, so then Rigel would be hotter because it is a blue star compared to a white star. All right, compare Regulus and Barnard star. Where's Regulus? Okay, Regulus is over here. And Barnard star is down here. So these two are on complete different areas. So they're kind of easier to compare. Looking at Barnard star, so it's at the bottom right area. So Barnard, I'm just going to put B. Barnard is going to be cool and dim. Whereas Regulus is going to be, it's going to be hot and bright because it's up in that top right area. Also, you could go in to say size. Regulus might be larger than Barnard. I don't know that though because they're both main sequence, so that doesn't quite give that away. But all right, guys, so that information there, I would look at it, recap before you started the rest of your assignments. But just remember, stars are categorized by the size, the color, and the luminosity. All right, these 3 things, organize them and place them on the HR diagram so that scientists can find them easily. When you're looking at the HR diagram, for temperature, the cool stars are on the right, and it gets hotter as you move to the left. And then for luminosity, the dim stars are at the bottom, and it gets brighter as you move up.